When we talk about the next generation of fighter jets, the Next Generation Air Dominance (NGAD) program led by Boeing stands out as one of the most ambitious and strategic developments in the history of military aviation. The F-47 NGAD is not just another fighter jet, it represents a completely new vision of how modern air forces plan to dominate the skies in the coming decades. To understand its significance, we must first consider the context. The US Air Force is seeking to replace its current F-51 fighters with an aircraft capable of operating in highly contested environments, facing threats from advanced missiles, long-range radars, and electronic warfare systems that could neutralize even today's most advanced platforms. If you're interested in learning all the secrets of the world's most advanced fighter jets, like this video and turn on notifications so you don't miss any details about the F-47 NGAD. The NGAD is not just about speed or maneuverability, it's a comprehensive systems concept. This means the F-47 is not just an aircraft, but part of a complete ecosystem that includes support drones, AI decision-making systems, and secure communications networks that enable it to share information in real time with other air, naval, and ground units. In other words, while a pilot is flying the F-47, they are supported by a swarm of autonomous vehicles, satellites, and command centers that maximize their effectiveness and reduce the possibility of loss to sophisticated threats. Although many details remain classified, public reports and patents filed by Boeing and the US Air Force offer some insight into the most impressive advancement. For example, there has been talk of a modular design, where different aircraft components can be replaced or upgraded without taking the entire platform out of service. This opens the door to a much longer and more flexible life cycle, where weapon systems, radars, and avionics can evolve alongside threats, something that wasn't possible in previous generations of fighter jets. Another critical aspect is stealth capability. Unlike fifth-generation fighters, which rely on reducing visible radar signatures, the F-47 NGAD seeks to integrate technologies that minimize its detectability both actively and passively. This includes advanced materials that absorb electromagnetic waves, fuselage geometries that scatter signals, and systems that can electronically alter its own signature to confuse enemy radars. The goal is for the F-47 to be able to operate in environments where the presence of outdated or modern air defenses is not an unacceptable risk, enabling deep penetration missions without relying solely on luck or tactical superiority. Propulsion is another fascinating element. Reports suggest that Boeing is working on engines capable of delivering variable and efficient thrust at different altitudes and speeds. With a special focus on fuel economy and operational sustainability, this means that in extended combat scenarios, the F-47 could remain on patrol for additional hours without immediate refueling, representing a considerable strategic advantage over more traditional platforms. Furthermore, the combination of advanced propulsion systems and optimized aerodynamic design promises a top speed and maneuverability that could surpass even the most agile fighters currently in service. The integration of artificial intelligence is another element that differentiates the NGAD from previous aircraft. We're not just talking about navigation systems or autopilot. AI could take over critical combat tasks in real time, from target selection to coordination with other allied aircraft and drones. This reduces the pilot's cognitive load, allowing them to focus on strategic decision-making and the execution of complex maneuvers. For example, in a scenario where multiple threats approach simultaneously, AI could automatically prioritize targets, suggest evasive routes, and coordinate attacks with other units in ways that previously required extensive planning and additional human personnel. The weaponry has also been designed with this new era of combat in mind. The F-47 NGAD is expected to carry a combination of long-range missiles, precision-guided weapons, and self-defense systems that will allow it to neutralize threats before being detected. Unlike current fighters, where the pilot must choose between carrying more weapons or maintaining maneuverability and range, the NGAD platform seeks a perfect balance between firepower, efficiency, and rapid response capability, all supported by intelligent control systems that integrate data from internal and external sensors. Finally, one of the points most discussed by experts is the possibility of the F-47 functioning as a central node in a distributed combat network. This means that it not only engages enemies individually, but also coordinates actions among various aircraft, drones, and defense systems, creating a cooperative network that multiplies the effectiveness of each individual platform. It is a concept of air warfare where information and connectivity are as crucial as the aircraft's speed or maneuverability. The NGAD program represents an enormous technical and logistical challenge. Each integrated system must function flawlessly together and withstand the most extreme conditions, from extreme temperatures and high altitudes to intense electronic interference. Boeing and the Air Force are investing billions of dollars in research, testing, and simulations to ensure that when the F-47 enters service, it will be a platform that changes the way air warfare is conceived. One of the most discussed aspects by experts is the flight testing phase that Boeing is conducting in collaboration with the United States Air Force. Although the details are classified, classified, public reports indicate that the F-47 NGAD prototypes have begun advanced maneuverability trials, engine evaluations, and artificial intelligence system tests in simulated combat scenarios. These tests verify that all systems function together, from the weaponry and sensors to the communication networks that connect the aircraft to other allied aircraft and drones. The complexity of integrating each of these elements is enormous. Any failure in a single subsystem could compromise the entire mission, so each test is meticulous and highly controlled. Comment below which of the F-47 NGAD's innovations you find most impressive. Its artificial intelligence, its stealth, or its drone coordination. In terms of propulsion, the latest NGAD prototypes incorporate advanced thrust vectoring engines, meaning the direction of propulsion can be adjusted during flight to maximize maneuverability without sacrificing speed. This offers crucial advantages in close-quarters combat scenarios, where agility can mean the difference between survival and being shot down. Furthermore, fuel efficiency has been optimized through lighter materials and an improved aerodynamic design, enabling longer missions without frequent refueling. Another key aspect of this development phase is the weapon systems. The F-47 NGAD is designed to carry long-range missiles, precision-guided bombs, and self-defense systems that allow it to neutralize threats before being detected. The innovative element is the ability to integrate future weapons through a modular design. This means that as new missiles or electronic warfare systems are developed, they can be incorporated into the aircraft without modifying its basic structure, ensuring the platform remains relevant for decades. The AI-assisted weapons control systems allow the pilot to select and prioritize targets more quickly and accurately, reducing cognitive load and increasing combat effectiveness. Artificial intelligence is undoubtedly a revolutionary component of the F-47 NGAD. AI systems not only assist the pilot in target selection but also coordinate cooperation with support drones and other air units. This transforms the aircraft into a central node within a swarm of aircraft and satellites, creating an ecosystem where information is shared in real time to maximize efficiency and survivability in hostile environments. For example, if multiple enemy missiles approach simultaneously, the AI can automatically prioritize threats and suggest evasive maneuvers, while coordinating simultaneous attacks with other aircraft and drones. In terms of stealth, recent prototypes have demonstrated advanced capabilities that surpass current fifth-generation fighters. The F-47 combines radar-absorbing materials, signal-scattering fuselage geometries, and active electronic jamming systems. This allows it to operate in heavily defended environments with a significantly lower probability of detection. Furthermore, Boeing has worked on integrating systems that can dynamically alter the aircraft's signature, blending in with non-hostile objects or simulating multiple platforms simultaneously, thus hindering the response of enemy air defense systems. One of the biggest challenges facing the NGAD program is the complexity of its production and maintenance. Each aircraft requires advanced materials, state-of-the-art manufacturing technology, and highly specialized assembly. Unlike previous generations, where hundreds of units with similar characteristics were manufactured, the F-47 will be produced in more limited quantities but with a focus on modularity and continuous upgrades. This means that each unit can receive technological improvements without being retired from service, a completely new approach for the U.S. Air Force. The strategic impact of the NGAD has also generated international interest. Military analysts agree that an aircraft with these capabilities could shift the balance of power in future conflicts, especially in regions where advanced air defenses are constantly evolving. The combination of stealth, autonomy, extended range, and network connectivity means the F-47 could perform critical missions that previously required complex coordination among multiple platforms, reducing risk to pilots and increasing overall operational effectiveness. Furthermore, the NGAD is not limited to conventional warfare scenarios. Its design allows it to operate in electronic warfare environments, where communication and radar systems may be overloaded or jammed. Thanks to its intelligent systems, the aircraft can adapt to changes in real time, prioritize threats, and maintain effective operations even when communications with the command base are intermittent. This provides a considerable strategic advantage over adversaries that rely on traditional radar and control systems. Recent trials have also evaluated the F-47's interaction with autonomous and manned drones, testing swarm tactics and real-time coordination. Preliminary results indicate that the platform can lead and synchronize multiple attacks, optimizing missile use and maximizing air cover. This approach reduces the need for a large number of aircraft on each mission, as a single F-47 can act as a central node in a broader network, controlling attack, reconnaissance, and electronic support drones. Finally, simulated combat testing has identified areas for improvement, from optimizing artificial intelligence software to adjusting propulsion and aerodynamics. Each iteration improves the aircraft's efficiency and responsiveness, bringing it closer to an operational standard that could redefine air warfare. Boeing and the Air Force continue to refine every detail, ensuring that when the F-47 NGAD enters service, it will be a platform capable of meeting any modern threat and adapting to future challenges. Don't forget to subscribe and share this video with your friends interested in military technology and aviation.